You want to state your name for the record?
Sure, Greg Porter at Skyscraper Guitars.
Uh huh. And
Yeah.
you build guitars, and you're a YouTuber, and you're kind of it sounds like jack of all trades, like just really interested in keeping the demons at bay by keeping your hands busy.
Yeah. It's kind of funny. I always tell people I don't really watch TV. I get bored really easily. And so I'm always trying to stay busy. So yeah, I have my hands in a lot of pots. And in fact, I'm an architect full time. That's what I do during the day. And then I come home at night and run the business with my wife. And yeah, so I'm a busy dude, but by
Okay.
choice.
We're going to talk about primarily your. Are you all subtractive, or do you do some additive manufacturing as well?
I have done some additive, but nothing other than prototypical work.
Okay.
Um, I find the stuff that squeezes out of the end of a 3D printer is nice, but it's not something you can really put for sale. I think when you're into plastics
Mm-hmm.
or other things like that, injection molding is probably the way that most people see a real product on a shelf
Mm-hmm.
if it's plastic. But the 3D printer is a super fast way to get from idea to thing.
Yeah.
And kind of, I don't, you didn't ask for it, but I'll give you just a tick of background on some of the 3D stuff that I've done and why I do so much of it. 2017, I got awarded an innovation sabbatical at the place I work. So the charge was to take 4 months and go out and do something innovative, and you had to submit a proposal and all those kind of fun things. And my topic was, well, how do I want to say it? The role of digital fabrication in architecture, so applied to architecture. And I got to go hang out in Boston at Autodesk's, they call it the build space. So they have robots, 3D printers, laser cutters, huge routers, milling machines, lathes, you name it. Anything that can make anything, they have it. And I got to hang out there for 4 months with guys from MIT and Harvard and all these really heady, scholastic places. And, I was well, I shouldn't say I was the dumb architect in the corner. That wasn't the case. But there were people doing like life-changing stuff. One of the guys there he had an amputation just below his elbow, and he was a mountain bike, like a super mountain bike rider before he lost his arm. And so he was figuring out how to make a prosthetic that you could mountain bike with and not kill yourself because you can't let go of the handlebars if and like was he on 60 Minutes? He was on some big national news thing. I'm like, oh my God, I worked right next to that guy. And oh geez, I can't, some of the projects I can't talk about because I don't know if they're public yet or not, but there were people doing things with spinning carbon fiber and making machines that could over the I'll call it an extrusion, but that's not how it worked. It worked like you were weaving a sock. I'll put it that way. So it was a sock weaving machine for carbon fiber, but you could vary the width of the sock as you
Oh
went,
wow.
and you could vary the cross section of the sock. It was the most fascinating thing I've ever seen. So anyway, I was out there for 4 months studying how do I apply this stuff to architecture, and all the while, all of these weird ideas I had about guitars and tools and how to make things were in the back of my mind. And it's like, okay, when I get home and I'm not on the clock anymore, I've really got to concentrate on what this means for manufacturing in the space of music or guitars specifically. So a little bit of background there. I had some access to the programmers
That's
who made Fusion, and
I'm vibrating with jealousy right now.
oh, it was like, I'm dead serious. I sent, like first I had to get chosen for the sabbatical, right? So you have to
Uh
submit something there. And then you have to write a letter to Autodesk, and you have to say, hey, I know you have this multi-million-dollar facility and you invite people in. Can I be one of those people? And, when I got the answer back, it was just like, holy cow, this is happening.
yeah.
And it was easily the coolest 4 months of my life. And living in Boston isn't bad either. That was a lot of fun too.
Uh-huh.
So
So you are you on Team Autodesk then? Are you doing all of your CAD work in Autodesk or?
most of, and so I started using AutoCAD in probably right around 1990. Jeez Louise,
Because
30 years?
CAD's been in architecture for some time, hasn't it?
Yeah. So
Yeah.
I was literally the first group of students that were getting taught how to draw on computers. So we did half by hand, half on the computer.
Oh my
So
God. Do
I
they even
can,
teach
yeah.
by hand anymore?
No, they don't. And I mean, it's kind of funny. Like when I write things down, people look at my handwriting and they go, "Oh, you're an architect."
Uh huh.
I'm literally the last year or two of people that you can identify by our
Uh huh.
handwriting.
Yeah.
And it's gotten sloppy now, but I can write like an architect. But yeah, so we were literally like my freshman year drawing by hand and learning all that. And sophomore year, all the teachers like had that panic, like you just passed a cop going 90, like, oh God, we're going to turn these kids out into the real world and they aren't going to be able to get a job because they can't draw on the computer. So somewhere in the middle there, my second or third year in school, it was, okay, we need to focus on the computer and you need to get really good at that in a short time. So I've been using AutoCAD for 30 years,
Hmm.
somewhere around there.
And so
So
AutoCAD's gone through a lot of iterations in that time. Like it's not anywhere near the same kind of what like vector graphics I imagine back in the old days and
yeah,
or
yeah, I'm trying to put that all in perspective. I mean, so AutoCAD was literally the way I would describe it. It was a digital piece of paper. That's all it
yeah,
was.
blueprint.
Lines, arcs, circles,
Yeah.
uh, rectangles, whatever. It would draw all those things. It would do them really well and really quickly. But it was just a piece of paper. That's all it
Uh-huh.
was. Like you could get it into the third dimension, but it was pretty rare. And there were a small group of us that were modeling things in AutoCAD in 3 dimensions, but it was really clunky and really difficult to do. So most people didn't do it. Nowadays, when you go into an architectural office, you won't see AutoCAD. No one uses AutoCAD anymore. They use a program called Revit, which is this 3D modeling crazy database thing that, like, if you draw a door, it's not just the drawing of the door, it's all the
It's
information that goes along with it. What kind of doorknob does it have? How many hinges? Da 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 da. And so it's changed. And in some ways,
is that also auto product or is that a different?
yeah,
Yeah.
yeah. So it's Autodesk as well.
Yeah.
Um, in the world of architecture, there's a couple small competitors, but they, like, if you want to be on the mainstream, you're using Autodesk products. Period.
Yeah,
It
they're
like
looking for, in the guitar world. I knew people that were doing Rhino and a couple other
mhm.
small ones, but yeah, it looks like Autodesk is going for like global domination of the 3D landscape. Fusion blew my mind when I because I had no experience with it, and when I started fooling around with it, what and realized how low the barrier to entry in 3D modeling had gotten. I just was like, oh my god, this is like we're dealing with Star Trek replicators are around the corner because like it just is not. I mean, not to take away from what you do, like clearly, but
Mm,
it's not hard to get into the software and
yeah.
bang something out.
I think if you're in product manufacturing in any way, shape, or form, and you're not using Fusion, there's some other SolidWorks, and I can't remember all the names of the other ones, but there are
Mm-hmm.
competitors to it. But the cost of entry for Fusion, I think I pay, I want to say it's like $200 a year, $250 a year
Mm-hmm.
for, and I don't have to. I do because I want the product to continue, right?
Yeah.
Like if you make with their software under $100,000 a year, it's free,
Mm-hmm.
right?
Yeah.
That's the claim, and I'm still there, unfortunately or fortunately, I don't know. I'm not in this to make $1 million. I'm in this because I love music, and
Yeah.
that's the end of it. And but yeah, so it's free to use, but I pay for it because I want it to continue. Like, I don't want the product to die. I don't
Yeah.
think it's going to, but what you get for that 200 or $250 is unreal. It's like, I don't know if you've gotten into any of the surfacing tools that they have. Most people don't know they're there because they're under a different tab when you're in the design space, I think. There's a video on YouTube about a guy modeling a shoe, like a tennis shoe. I watched that video and my head just split in two. I'm like, you can do that? Like, it was this crazy surface thing, and I can't explain it other than
Are you
in a
talking
matter
about
of 30.
when it kind of like turns purple, and then you have kind of all the different points you can pull on and stuff like that? Like, is that the surfacing stuff that you're talking about?
It's a little bit that way, yeah. So you can literally start with one square, right?
Mm-hmm.
And then you can grab an edge and you can copy that edge in 3 dimensions, and then you can start to warp it and do all these things.
Yeah.
What Fusion has, and I'll get a little nerd on you for just a second, and then I'll stop. It has, I think they call it fourth order tangentiality.
Mm-hmm.
Don't quote me on that one. But there's like, if you have a 2-dimensional circle, right? You can draw a line that's tangent to that circle. And so a spline is kind of that thing, right? You can do as many dots and they're all tangent. Yeah. And then you can start to do that in a 3rd dimension. And then you can do it where a surface is tangential to multiple things. And it's like the holy grail of computer modeling. Fusion has that. No one else, my understanding is no one else has that. As far as making guitars and instruments and things that are very surface oriented, what an incredible tool.
It really is. I haven't used it probably since about 2016 or 17, I think. And I tried to model a F5 mandolin neck, and it wound up with my wife looking at me and going, "This is not your job. Why are you getting so angry?" But I will say, I got to where I had the peg head and I had the heel. The heel was actually the challenging part, because you got those curves around inside the dovetail and stuff. And I got it done, and I don't know anything about it, other than watching YouTube videos and I didn't go to school for it. So a layperson can use that, like I'm sure a smarter layperson could use it to great effect. So it's pretty crazy, but I can't imagine where it's come in just a handful of years.
It's there's other software. I've used Rhino. In fact, fun stuff. I bought a copy, like, I think it was 1.0. It was back. Was I still in school, or maybe I had just gotten out of school? Early 90s, somewhere in there. And Bob McNeil is the dude. It's McNeil Software, right? Mm-hmm. And I had to call them to get a license transferred because I bought it used. I bought Rhino used. And I talked to Bob McNeil. Like, he was the one who, hey, welcome to Rhino. It's like, holy cow, I talked to Bob McNeil. And now they're this big grown-up cool company that a lot of people use. I think PRS, no, they don't. They use SolidWorks. I saw one of the big boys using Rhino the other day. It was kind of fun to see. So, but yeah.
They all seem to approach the 3D, or how you manipulate the 3D space, just a little bit differently, like that the Fusion one of like having all those different points that you can pull on is really interesting. If I was trying to do something, I don't know, I'd have to work with it again. Do you have your computer handy with Fusion?
I have it upstairs. I can grab it for sure. Do you want me to?
Yeah, I think it would be cool to take a look at what you're doing.
Okay, give me just a second.
So the thing about Fusion too is it's almost like social media too, right? Like it's like you can have Fusion friends, and you can share your designs with people, and isn't it kind of like almost like a social space as well?
So I've got the machinist who does most of my production is in Indiana, and I'm in Colorado. And I go in and I draw the thing, and then he goes in and cams it out the way he wants to do the cam. And we just share the file on, like, I can see what he's doing. He can see what I'm doing. It's like, it's the most awesome thing ever.
Yeah.
And I explain it. It's like a McDLT.
Nobody's going to know what that means except guys our age.
I know. but it, like, the design side is the design side, and the manufacturing side is the manufacturing side, and they can't like cross over.
Yeah.
And so when I do the design, he's free to do whatever he wants in that file, and it's not going to screw me up.
Yeah.
And that is so valuable.
Yeah.
Like, yeah. And the fact that he can call me and say, "Hey, Greg, I can't get a tool in to access this part of what you designed.
Mm-hmm.
Like, let's look at it together." And we can look at it together. And as we're on a call or on, whatever, well, I guess that's how we usually do it. It's just on the phone, but then we go back and forth, or we get on a Zoom call and put Fusion up, and I can interactively sit there and design it, and he can take it and cam it, and the problem gets solved like immediately. It's yeah.
What's interesting is I could probably pull Fusion up on my camera and stream the window, and because we could collaborate on Fusion together, correct? Like in real time, like do a drawing. One of the things I'm going to do is Ted Bergstrand did the 3D printing stuff, and part of my segment is I think I'm going to have him. Have you seen Tinkercad at all? He was going over Tinkercad, but I'm going to have him run Dan Earlywine through the little opening tutorial phase of Tinkercad, and see if we can get Dan into the third dimension as well.
I'll bet he would pick it up like that. Because here's the thing that I've seen, right? Like, there are people who can process three-dimensional things in their mind, and there are people who can't. And that's okay. Like, nobody's bad because they can't do it. But people who work with their hands all the time on three-dimensional things, I don't care what they are. Just a carpenter, somebody who frames houses. They work in the third dimension all the time. They get into those programs, and it's just immediate. And they're like, "Oh yeah, this is a piece of cake. Yeah, that's how that wall would sit on top of this thing." And I used to have builders when I was a young man. I worked all day at the office doing architecture, and then I would have guys who built houses come over at night, and we would design houses and kick out model home plans and things like that for them. Just make an extra buck here and there. And whenever those guys were there, they were so fast at understanding how the CAD model was going together. You take somebody who doesn't work with their hands or doesn't do anything like that, it's an eternity to get them to realize how things extrude and void out and all those kind of things.
It's something. The division of labor in my marriage is definitely on the 2-dimensional, 3-dimensional criteria. I'm in charge of the third dimension, anything that's either gross or cold. So
that's probably similar to my arrangement.
Yeah. But oh my God, if I had to read a legal document, I mean, forget about it. My wife is I constantly call her the reader of the outfit. Like I'm just like, oh boy, my reading comprehension has gone to crap. But yeah, I can rotate things in my mind in the third dimension.
I'm that way with accounting. Like, forget it. Like, I get it. I understand numbers. Like, I'm really good with math and all those things. You got to be, I suppose, to be an architect. But accounting, I get it. It's just simple addition and subtraction. But my mind doesn't. I can't get there.
Yeah.
And it sucks. It's like it's so easy, Greg. No, forget it. Somebody else can do it.
Somebody else can do it. People get paid to do stuff. Show just like if you were gonna like. Kind of the process of going from a sketch to an extrusion or something like that. Just a real basic, like, hey, I want to make a, maybe how you would potentially.
I'm trying to figure out how to flip my camera around.
Okay.
Is it that?
That's
Okay, cool. So check this out. So there's that quote from the other day that is hanging by my desk. That one will never come down. I know it was probably like this moment in passing that nobody else thought was interesting. When I heard it, it was just the passion in Dan's voice.
Yeah.
Because, you asked him, how much do those cost? He's like, it doesn't matter. Just the way he said it, I was like, oh, that's so good. It is so true. So I'm going to have to figure out a way to set this camera where I can actually use the keyboard.
Do you have one of those little cheap tripod thingies?
So I got like this little mini Gorilla Pod. Hang on.
That's cool.
So that thing.
Oh yeah.
Yeah. Uh, so there we go. That's something you can see,
So
right?
this is your trim setter, correct?
Yeah. So this. Hang on. Let me grab the actual part. So, and I'm not talking now. Hang on. Let me. Well, no, that's okay. So there's the actual one,
Uh huh.
right?
And this is manufactured by your friend in Indiana.
So no, this one I made this morning.
Uh
So
huh.
this chunk is brand new. Hang on. I'm looking for the. Here we go. Sorry.
It's
This
all right.
is I'm flipping things around. This is the one that we sell now. So this is just for Floyd Rose.
Uh huh.
Okay. Normal original Floyd Rose intonation. And everybody has been asking me, can you do Ibanez? And so I'm trying to figure out how to get a tool that works with, and I'll just hold them up. I have a bunch of Ibanez
Uh huh.
tremolos sitting on my desk to make sure it works with everything. So yesterday I made prototype 1.
Uh huh.
I feel like I'm doing a puppet show. Prototype 1, and the foot on it, the way Ibanez is, as you would tighten the tool, it would actually kick down.
Uh huh.
So this morning I redrew this foot.
Uh huh.
And so this was like, I got up at 8 o'clock this morning. I redrew the foot, and then I recammed the whole thing. So I make all the prototypes, and I recammed the whole thing and then spit this out. This was done before noon today. So if that tells you anything, just in a matter of a couple hours, changing the design.
From idea to prototype in an afternoon.
Yeah.
That's crazy.
So like, I don't know. I'm trying to think.
Oh, do you have do you have the? It would be good to showcase the previous iteration. Is it still in the history infusion or?
Ooh, yeah. So you can. Oh, I don't know how this is going to affect me because I don't do this very often. But can you see? Hang on. Sorry for the shaky cam. Here in the corner, there's.
To your right, just a little bit.
Oh,
There you
there we
go.
go. Sorry,
Yeah.
I got to look through everything at once. It will take you through every version that you've done. So
Uh
I've
huh.
done 11 versions of this tool, and at any time I can go back in and open that tool,
Yeah.
and everything will come in with it.
Cool. And
So
that's all server side too. That's not on your computer, correct?
that's correct.
So you don't
Yeah.
so you don't have to like have a terabyte of or
No, it's free storage. I don't know up to how many. Sorry, a shaky cam again. Um, it's free storage up to a certain amount, and
hmm
then I think you probably, like everybody, you have to pay. But I pay for a subscription to it, so I think I get a bigger
hmm
hard drive access. But I'm not going to swear to that.
Can you rotate that just a little bit in the space there? Yeah. That is such a
Yeah.
slick
So
program. So you
then,
can really get around it.
so this part, what's awesome, like all of my fasteners, like this thing, socket head cap screw.
Yeah.
You can just go in and insert from McMaster Carr. I don't know if
Oh,
you're
that's
familiar with
right.
them.
Yeah.
And you can anything that McMaster Carr sells, they have a 3D
They have
model
a 3D
for.
model, and
And
it just
then
saves you all that
I
time.
I buy, like, these are my steel pins. I buy them by the hundreds,
Uh huh.
and I know when I go in and insert a model from McMaster Carr, it over here on this side, it actually has the part number. So when I make this and I say, yeah, that's the screw I want to use, there's the part number right there. I can just order 500 of them.
Oh my
And
gosh.
like, that was a game changer for me.
Yeah.
So this is what's fun is there's actually a timeline, and you can see how this thing was built. So you can literally go step by step. Give it a second to catch something that's real.
Can you go
Maybe I'll
back to
turn
the?
on.
Can you actually go back to the sketch that you started with, or?
Yeah, that's what I'm getting ready to do. So let's turn that on. So this was, I went in and measured with my calipers, which are up in my shop right now, to the thousandths, where all the clearances were in this tool.
Yeah.
Or sorry, not in the tool, in the actual bridge.
Yeah.
So just taking the calipers and where do I need to go. So these are all the rough measurements of, hey, I need something that sticks down over here. I need a foot to catch something over here.
Mm-hmm.
And then I need this much vertical clearance. So these are all like, if I go in and edit this sketch, maybe, yeah, you can see all the dimensions.
Mm-hmm.
So one of these is a minimum dimension, 1.68 inches. I have to be able to pull it in that far. So this is like a dummy where that hook would be that catches the saddle. Then this is where it needs to extend out to. And so if I do that, it's 2.31 inches. Okay, great. Then from this breakover point, I need, 0.65 inches and on and on and on. So this is all dimensioned up with how I think it should go together. Cool. Then let me hit that. So then I'll bet I think it'll show how I brought these things in. I got to turn things on as they go. Then I brought in that half of my tool. So this is the back half or the hook half of the intonation tool I currently make. And I wanted to use that so that this can be, both Floyd Rose and Ibanez with the same half. So you just swap out the hook end, this end.
Okay.
So I brought in this model that I already had made. So we've been manufacturing those for a couple years. So I brought that in and it was like, okay, how do I interface that? And so I'll do it from the top here. So this is stretched out to the maximum. Then here's maybe what the body of this thing is going to look like. So, drawing the same lines and making things parallel and that sort of thing, but then going down and capturing that detail from my sketches, right?
Yeah.
Then next step was to take and extrude it. So I'll back up a step. I basically took this form and pulled it up. So, and I'll do this and just kind of undo it. So you just hit the extrude button, you hit this guy.
Yep. And your constraint is there to the left, correct? Like you've got the geometry to the left there that's telling it how far to extrude, correct?
Yeah. So let me try this again. So I can do like this, right? And just stretch it and say, hey, I know this is 3/8 of an inch. Or you can start to snap to things. So that would align this. And then you can say, actually, I want it to be a 2-sided extrusion. And I'm going to grab this bottom side and I'm going to make it that. So without knowing the measurements, I can make this thing exactly the same thickness as this thing.
Yeah. So it's
Did that make sense?
Yeah, it's snapping to the already the geometry that you have there, correct?
Right. And so you could, and I'll just kind of show a couple things. If I needed to move this face, like if that needed to match up over here, you can do what's called a press pull, and then you can say it needs to go to there.
Yeah.
For some reason, if I needed to start that way, I could do that. But I'm going to cancel out of this and undo that so that we can take a look at this timeline. So I extrude the thing, right? And it's not exactly what I want yet, but it's close. Then kind of moving things around. Some of this might be boring.
No, keep going.
In this one, I created, let's see, I think it was sketch 3. Yeah. I created a sketch on this back face, okay? Because I wanted to take away a chunk here and a chunk down there. So I'll step back one, maybe. Yeah. And I extruded using this sketch. I extruded into a void, and I'll show it happening. So there's that and that, right? So that makes the foot nice, how I want it. And then we can actually go backwards, and I can show you how that happened. So you can create an extrusion. I can select this piece and this piece. And then as I pull it through, it's going to turn red because it's creating a void.
Yeah.
So you can see how it cut that piece out.
Yep.
And I know this is iPhone through computer screen, whatever. You can tell it to cut. You can tell it to intersect. You can tell it to be a new body. You can tell it to join. However you want that to happen. Here we want it to be a cut, right? Because I'm taking material away. So that's the step I did to get that piece and that piece. Then the next is starting to chamfer it. So that's these edges. So I don't know if you caught that.
So yeah, the chamfer, was that also part of a sketch, or is there a chamfer feature that you can?
There's a chamfer tool here, so I can just select any edge like this one, and you can just start to pull it, and it'll chamfer whatever dimension you want to chamfer it.
Cool.
Which is slick. And so part of this is like utilitarian, right? What size does it need to be? How does it need to function? And then part of it is, how does this feel in the hand?
Mm-hmm.
And if you hold something with nice chamfered edges and you're working with tools all day,
yeah,
this is way nicer than something with square and sharp edges.
Absolutely.
So there's a little bit of that tactile that I'm always looking for when I design things. Like, yeah, that works, but how does it feel?
Yeah.
And so this, go ahead.
Oh, like with we talked before about Frank Ford's string winder. Like there's something that
Yes.
just that feel like I was like, oh my god, I have a real job or something, like.
Yeah, and I've got some tools in my shop I'll show you that are very much that way for me. Like I paid way too much for them, but they're so awesome, you have to have them.
So the name of the game in Fusion is making sketches on planes and pushing and pulling and extruding. It's like it's so approachable, like.
So this is exactly what you're talking about, Ian. So right here, I created this sketch, which is just 4 lines, one of them at an angle with a little bit of a radius there. So there's a tool called a Filat Tool, and you can just tell it whatever radius you want. I think you can actually, even if you're not in the sketch, there's the, nope, I'm wrong. Some things you can change in the 3-dimensional non-sketch environment, some things you can't. But if I wanted to edit this sketch, I just double-clicked it, and I could bring this line up and change the way this tool goes. So if I'm and I'll undo that, I'll step to the next piece. That followed my sketch, right?
Mm-hmm.
So if I undo that, I think I'm going to just say undo again. Because this is a real working model, so I can't screw it up too bad.
Don't mess up your thing just to impress YouTube.
I can always close it. I can always close it without saving. So everything starts to get messy when you have all your sketches on, but you can. I do tons of little reference things that help me out somewhere along the lines. So yeah, you can see we started with this really blocky 2-dimensional extrusion. We cut off a cheek, we chamfered it. I cut out this back thing so I wouldn't have to have a screw that was like 4 inches long, or I'm exaggerating there, but it took about a 1/4 inch off that screw, which makes the, long screws get wobbly, right?
They do.
So you want your screws to be short, and
long screws are also more expensive too. So
they are, and these are tiny. This is like a, where's one of them at? Do I have one? My computer's sitting on top of my screw box.
That's fine.
But they're like tiny little screws. Oh, here's one. And tiny.
Mm-hmm.
And so making that a 1/4 inch longer makes it way worse.
Yeah.
So just trying to keep everything short and compact and all those kinds of things. But stepping through, I can't remember the order of things I did next. These are probably, I'm importing screws here. That's what I'm doing. So this, you can see the screw come in from McMaster Carr. And then there's probably at some point, I'll flip it around. Maybe. Yeah, there we go. So now that was where I put the screw into place. And so this is so that I can grab that piece and move it and see, there he is. And see, when I collapse this tool, is the screw going to come out the other end? Is it too long?
Yes.
Okay. Now you can put together sliding joints and you can do all that kind of stuff. I just kind of get in and do it by hand, but you can look, hang on, I'm going to spin that. Basically, I knew I needed to get the hook to this line, right? So as I move it, and again, just kind of looking for, okay, there's kind of the final resting place. Oh shoot, I just hit escape. Let me try it again. So this will be exciting. We may have to edit this out, Ian. But
no. I'm all in.
There's the final resting place, right?
Mm-hmm.
Then I can go in and select this screw, and it's kind of like an X-ray, right?
Mm-hmm.
Like, oh yeah, I got a couple thousandths of clearance there at the end. I'm good. And it's literally, sometimes it comes down to a thread or two does this design work or does it not work?
Absolutely.
So
And who wants to be cutting the end of this, 10,000 screws off,
yeah,
because you screwed it up.
yeah, and you can't. So if that happened, I would either add material here or
Mm-hmm.
take it away here. That's my
Yeah.
sort of like safety valve, right? So then as we go through, again, just the detail, the chamfers, and you'll see in one of these next ones, I start to add these little things. So these tiny little chamfers, I need to turn the sketches off so we can see these tiny little chamfers here.
Oh, wow.
These are 7/1000 of an inch.
Uh-huh.
Okay, so twice the size of a human hair. But if you don't do them, all of your edges are sharp, and when people grab your tool,
Yeah.
it hurts.
Yeah.
And you won't be able to see it. It'll just be a sharp edge, and it's not good.
Yeah.
So we go through and we break every single edge on everything that we do, unless we just can't get to it. So you'll see those chamfers. I probably have next is, those chamfers, and then the last ones will be on this back edge there. So the whole tool, as you hold it, is not going to be sharp. And that's, I don't know, that's something I see a lot of people water jet cut tools.
Mm-hmm.
The big one is these things. Hang on. Sorry. I've got to reach across my not straight edges.
Yeah.
A lot of people just water jet cut them and they sell them, and they're cheap and they're nice. I mean, they work. We machine them, and every one of these has a micro bevel on it, because if you've ever picked up a notch straight edge and it's been sharp,
Yeah.
it'll scratch your guitar like in a heartbeat.
Yeah.
And I don't know. I just can't have that.
Yeah.
And I'm not trying to brag or sell tools or anything. That's not my point. I'm just saying, when you're designing things, it takes care. You have to take care of things like that.
Absolutely.
Then on the machining side, I think this is the fascinating piece. So I'm going to turn off that part of the tool and the screw, because really we're just machining this.
Mm-hmm.
And so the manufacturer, the surfacing tool, by the way, is this one here. So you get into all these weird, cool tools. That said, the manufacturing side is where the rubber hits the road for me. So this whole thing, this little tiny piece, takes 4 operations to make. So I have to set up and do the holes in this end,
Mm-hmm.
which is, it has some beveling and some other things that we do. So essentially, the piece of material, if I can get this thing to cooperate, is set up in the vise, and I'll turn that on. So the block of material is set up in the vise like this. And then the fun thing is Fusion will actually let you see how this thing's going to be made. And I have all of my tools programmed in. So I'm going to change this to just the shaft. I'm going to turn the stock on. I'm going to turn the model off. Okay.
So you have a Tormac, correct?
I do.
And so is Fusion, like, are a lot of these measurements you go, I have this model Tormac, and Fusion goes, oh, okay, I know what you got, and then it does a little bit of the heavy lifting, or you got to do a lot of that manually?
You do all of the heavy lifting yourself. So
Uh-huh.
I have a tool library, and these are my tools. And every one of these, if it's a drill, I go in and model what that's like. But then there's cutting data. This is all from me. How fast does it plunge? How fast does it move? What is this tool all about? And you sort of find these recipes as you go that work. Like this particular design, yesterday I broke a number 30 drill, which is it's 1/8 of an inch. Let's just call it 1/8 of an inch drill, because this hole has to go almost all the way through this inch thick block. Well, when you're using those tiny little drills, drilling deep holes, it's really difficult to do without breaking tools. So I had to go in and reprogram the feeds and speeds on the number 30 drill to cut it like in half so that it could clear out chips and do all kinds of craziness. But you can actually, I'm sure you've probably seen this, I can simulate what this thing's going to do. So that's my first operation, is it leaves that part of the tool. And then the fun thing is, I'll do this and we'll do it in fast motion. I can grab all the setups at once so we can watch how this entire tool gets made. So I'll do that. I'm going to turn these tool paths off because they'll get in the way. But you'll watch. So we're set up from the top. This one, I have to set it up flat. and then it'll cut things out. I'm going to speed it up a little bit because this is going to be really boring. So it's going to take away that kind of material, and then it'll change tools here in a second and kind of clean things up from a smaller diameter perspective. There's it cutting that pocket. That's the cleanup. It's putting bevels on. And now it's going from the other side. So I'm going to hit pause and flip this over.
So in the machine, you would have flipped this, correct?
Yeah.
Okay.
So I'll turn the tool off for a second. So in the machine, I flip it over and it has what we call a top hat on it.
Mm-hmm.
And it's because you have a vise on that your piece gets held in, and you can only cut down so far before the part just flies off. So you have to leave a little bit. And then I flip it over and put it back in the vise, and then it cleans off that top hat.
How are you registering that so that it knows where it's at on the part?
Okay, I'll show you that in just a second.
Okay.
But I'll show you that in just a second. So here, and then at some point, we're done. So that's my whole tool. Every color represents the different tool path and a different cut and all those kind of things. So you can see in this list over here to the side, that's how many tools and how many operations, I don't know, I'm going to say it's 20 that the machine has to do. And you have to tell it, hey, I want to do a spot drill with this size drill. I want to use an end mill to carve out this stuff. It's this big. Everybody thinks that you just sort of hit a button and the machine does it. The machine is dumb. It's really dumb. It knows how to move and put things where you want them, but it doesn't know anything.
It also knows how to break your bits.
You can snap off a few $100s worth of tools in a weekend if you're not careful.
So get into that. Knowing how those tools work. I mean, that's something people go to school for. Do you have resources for, what do I do with this cutter kind of stuff? Or did you just go online and just read everything you could and that was good enough, and you were willing to break a few tools to figure out what was going on?
So I think anybody who makes anything has the same attitude. Like, I don't care what it takes, I'm going to make this thing, right? Like, you have to have that no fear, damn the torpedoes attitude.
I got a lot of fear.
Well, now there's healthy fear and there's unhealthy fear, right? Healthy fear is I have a 1918 whatever, fill in the blank in front of me, a fiddle or a guitar or Martin Brothers, whatever.
Yeah.
You don't want to screw that up. That's healthy fear. I've got a blank chunk of aluminum that is nothing right now. There should be no fear, right? You're starting out with something useless and you're trying to make something useful. So you can't screw that up. If you wind up with something useless, it's a no-sum game, right? Like, nothing ventured, nothing gained. You're cool. Mm-hmm. You didn't cost somebody $1 million or their prized possession. You don't have to explain to anybody why there's a chunk of aluminum in the trash. So, right? Like,
yeah, I'll have to explain to myself. Like, it hurts. Something deep within me hurts. It hurts to fail. I try to get over it because it's a really unhealthy habit. But I don't know if it was beat into me when I was a kid
Well, I have the same fear, and I'm going to pull these out. We talked about this before we went on the air. My watercolor paints, right? I think this tube of paint probably cost $30 or $40, right? It's an artist series, Winsor Newton, like the best you can buy. And when I started painting, I was afraid to screw up paintings, and like paralyzing. The paper I just bought cost $15. And I've got a $40 tube of paint. And I realized at some point, if you don't do anything, the paper is going to be blank and the paints are still going to be in their tube and you've gotten nowhere. And so I don't remember who kicked me in the rear end and basically was like, you got to get over that. And you got to paint a bunch of garbage paintings and get it out of your system if you want to get good. And I did. And it worked out. And it was awesome. And I think that was part of the thing. Like, chunks of wood and other things, they're just chunks of wood. We're trying to make them into something really cool. And so back to this thing, right? I could not have gotten to the one I worked without screwing this one up or, making this one that doesn't work. And I've got this one up here that I made out of wood that totally didn't work. And I'm not going to manufacture them out of wood. I do little prototypes sometimes out of wood just because they're fast. Mm-hmm. And sometimes I can do it on a table saw or a drill press or something and just get the idea out of my mind. But without this failure and this failure, I wouldn't have gotten to the one that works. Like, I have to fail in order to get to where I want to go. And it's such a weird thing. And I know as an architect, like, people say, well, we can't really fail. You have a failure and people die. And that's not good. But out here, I'm in a completely worry-free zone. I can screw up as many things as I want. At some point, I'll run out of money, but...
Well, that is an issue. You know, in architecture, you're standing on the shoulders of failures before you, though. All of those codes that are written were written because somebody didn't take something into consideration, and there was a failure. So, you know, somebody failed, and maybe you'll fail, and a new code will be written. It would suck, but you know.
and we have failed. We're not perfect, right? We have failures, and it's mostly in ideas and concepts. Like, I thought this space would work really well if we did this, and then you get in there and you see people use it, and they're like, "Wait a minute, he's not sitting in the right spot, or that furniture moved from where we thought it would go," and you know, everything's a win, right? The buildings aren't falling down. It's just different than what you thought they would be, and you learn from that too. But yeah, I don't know. I mean, this is kind of fun. Where are these pieces and parts at? Sorry, my desk is a little bit of a mess. Oh, here we go. Making a string winder. There we go. There's something that nobody's seen.
Man, that is some shiny stuff. Holy cow!
It is. It'll get anodized, but I'm sure I said string winder, fret bender. Most of them have like this thing on the top and another thing that you tighten down to keep the thing from doing it. And I wanted something with a simple mechanism, so it's just a single screw.
That is really
nice.
Goes
up and down, but then if you can see on the face, there's like a radius gauge, so you can tell.
Oh, look at that! Look at that. I got an idea for an add-on for that, by the way.
Go for it.
I'll have to rethink how I did it, but I made one with a fret D-bender. Because a lot of times you gotta go the other way, and basically it was kind of like an outrigger that came off and pushed down on it to deradius it the other way. But
I'm trying to think. I had it sorted in my head one time that if you raise this middle one up and you turn your fret wire upside down, that it would come back through straight.
Yeah.
I think I haven't tested that on this, so. Again, like I feel like there's some part of me. It's like, Greg, you're just copying a tool, and I have this huge fear of being labeled somebody who copies. Right? Mm-hmm. I always want to improve whatever I'm doing. So I'll use this as an example. I think you've seen these. So my fret rocker. Mm-hmm. Everybody's out there making these water jet cut fret rockers for like $3, and it's okay. I'm not going to, poop on those people. But it was like, well, can I make a gauge on here that can actually help me see what my string height is, off the fretboard and my string action? And I looked at all the different string action tools that I had and like what works best. And for me, it was like a white line and a stair step so that you can compare one to its neighbor and see, am I on or am I off? And so, okay, that's an improvement. It's not a copy. Okay.
Well,
and
I think even if you are copying, like when I look at that tool and it's nice, guitar repair people, and talked about this quite a bit, but it's such a new, it's basically a new profession. And I mean, you look at any guitar repair guy's bench and half of his tools are just, garbage that he fished out of the trash can and put a notch in it and then hung it up. And when you're dealing with stuff like that. And when you're dealing with a customer, like there's a lot of times where the customer is back in the shop. And if you're, like I hate to be one of the guys that's like a set an impression thing, but if you have really nice guitar specific tools that have a little bit of feng shui about them, I think that's helpful. It's like It's like pulling Frank's crank rather than one of those cheap D'Addario click clack plastic things. One makes you feel like you have a profession, the other makes you feel like you're a punk kid in the back of a music store.
Yeah.
So I don't think there's any shame in taking existing tools and putting a stylistic spin on them. So even if that's what you're going to do, if you can improve them, that's great too. But I mean, the orange anodized looks really sharp, by the way.
Well, this was one of the things I was fiddling with earlier. So radius gauges, but they're clear, see-through, and of course orange because everything in my life apparently is orange these days. But I've got those, and then I've got these are. I'm showing off some prototype things. None of these are for sale yet. Some of these where we actually cut the logo through it. A really good friend of mine does amazing laser work.
Yeah.
And so he made a handful.
What are the 3 notches there on the edges of those?
Oh yeah. Hang on. So again, I always try and improve, right? Like a good copies do Mac. And so this is a center line, right? And then sorry, I'm probably off camera. This is a center line, and then this is a standard nut width.
Okay.
So the idea is if you put it on your fretboard and you want to find a center line, there's enough of a mark that you could say, okay, 1 millimeter from this edge and 1 millimeter from that edge, and center something up. If you're trying to locate a dot, there's a handful of things that I've been, I wish I had my center line on a radius.
Oh my God. You just made me think about putting the nut layout marks on the radius gauge. That's a different idea.
And I've thought about that too. And again, Stu Mac has that really crazy cool ruler that allows you to sort of slide it one way or another, and the marks for your nut slots get a little wider or a little narrower. And I keep banging that around in my head. Okay, if you're going to do something like that, we're not going to copy. I'm not just going to make one just like theirs. I'm going to make one that does something a little bit nicer or better. And if I can't, I have a rule. I'm never going to compete with somebody on who's the cheapest, because I can't. All my stuff, again, we make everything here in the U.S. I don't see anything offshore. And it's like I can't compete if I'm just going to copy something. So there's always this push for an improvement. And I've seen people make copies of my tools, which is kind of funny. It's flattering and it pisses you off at the same time. It's like, oh, at least make it better. Like, one up me. I don't care if you one up me, but do something. Don't just copy it.
Well,
some guy,
Stu Mac will copy you. They've got no
that's okay.
compunction about doing that. But
maybe I should say, for every one they copy of mine, I'll copy one of theirs. But no,
well, if you get to know Dan too, like they're also pretty. They're good about reaching out to indie tool builders too, and getting because they've got a big operation and manufacturing all that stuff themselves. I mean, like all of their finish, or not all of their finish, but all their color products comes from Jeff Jewett from Homestead Finishing. Like he outsources to them, and but yeah. Anyway, just something to think about. But I really like your stuff, man. I like that. I like the design aesthetic. I like that it looks like like you said, it doesn't look like something cut out on a water jet for the cheapest amount of money possible. Yeah.
And again, and I try not to get too on my high horse about this, but I think for sure in the guitar world, a lot of tools were just made like very utilitarian. Like, I need this thing to do this thing. Like you were describing the kid in your shop with a screwdriver, like poking it at things because he knew it needed to go in there somewhere.
Yeah.
And it's that type of mentality of, well, I got to have this thing that does this thing. And that's sort of like iteration number one, right? There's the idea, there's the thing, we're done. And it stops there. And then over the years, you see 15 different companies make the exact same thing with the exact same mistakes. And they never think too much about that tactile and the user and like, how does this really over time, how does this work? And, you you can develop carpal tunnel in a heartbeat if you're doing things wrong, if
Oh,
you're working on
absolutely.
stuff with your hands. And so just try to take those things into consideration. But like, and this is such a simple, stupid thing, but it took me forever to find. This is a sanding beam, right? Just a little
Mhm.
short 6 inch, yeah, 6 inch sanding beam, but the corners are radius. Because if you've ever had the ones that are made out of the steel tube with the square edges on them that somebody put on a grinding machine until everything was like chef knife sharp, you can screw things up. Like you accidentally touch that corner of those things to a guitar, bing, now you're doing a finish repair.
Yeah.
But yeah, if you drop it on, or if you set your guitar on it, you're in for a finish repair because you just dinged it with the corner of that thing. There's like one company out there who makes a radius tube, and it took me forever to find them. I didn't make these until I found it. I'm like, there's no way. I'm not going to be
Is
the
that
next guy who does the thing with plastic caps in the end. And
is that aluminum or is that steel?
it is. It's aluminum, so it's a little bit lighter.
Cool.
To be perfectly honest, I prefer the steel because it has enough weight that you just sort of float it across the frets when you're doing a job like that. But I've also got, it's in that box right there, Crimson Guitars. If you know Ben Crow, he's on the internet too, or on
I've
YouTube
watched
as well.
his videos. Yeah.
I've got, where is it? I got to dig for just a sec. There it is. This beautiful file for fret leveling. This is like, and I know there's other people who make them like this.
Mm-hmm.
His has a truss rod in it.
Oh, really?
So if it develops he doesn't make them like this anymore. This is old because the truss rod was taking him so much time.
Oh,
But
no.
if this ever gets out of flat, I can straighten it. This is like when I got this, I was like, Ben, you're so awesome.
That's pretty cool.
I love Ben. I've been following Ben since he was in his garden shed in the backyard before he had any employees.
He's back in the garden shed. I saw the other day because of the COVID thing. He's back in there doing his thing.
He is. I sent him a note. I thought that was hilarious. I'm like, oh, you're back to where it all started. This is great.
Yeah.
But like, this does an awesome job on frets, and it did an awesome job. And it, the weight of these two is almost the same. So, it's not as big of a deal. You can put a little bit of pressure.
Yeah.
I'm working on, there we go. There's a StuMac thing. These little guys. I'm so frustrated with this thing not doing what I want it to. I've redesigned how that's going to work for me. Again, taking something that exists and improving it, right?
Uh-huh.
I'm not going to tell you what I'm going to do because I'm not there yet. But this is going to be my go-to for doing fret work. And not taking necks off guitars. I'll put it that way.
Cool. Yeah, I'm all about hearing that. Let's see. Do you want to take a look at your machines?
Yeah. First, I got to show you this though. This is like the coolest thing that nobody else has. And
this is a Skyscraper exclusive.
There's my warehouse back there, just for funsies. So flip this around. You've seen one of these before, right?
Yeah, man.
So we're gonna watch this as it comes up. My serial number. I just got this back from Peterson. It had to be repaired, and it lost its serial number in the data. So they put in a custom serial number. So it'll say Skyscraper as my serial number. I don't know if you caught that when it came up.
Oh yeah.
Sometimes
man.
there. Hold on here. So down in the corner.
Oh,
Skyscraper is my serial number on my Peterson. I think I'm the only one who has that.
Man.
So anyway.
It's hard. I don't even think they're making those strobes anymore, are they?
I don't know. This one had all the old electronics in it. I can't remember what year it is. It's old. And when I sent it in, she said, "Oh, do you want the updated something or other?" I don't know if it was a different color screen. There's something different about this one from when I sent it off. It's like, yeah, I don't care. I just want it to work because that's been my guy for years.
Yeah.
It's like, yeah, and I've got the this one as well, but and this works well. But I like the old Peterson. I like to hear it hum in the background. It makes me comfortable.
Yeah.
So yeah, I'm gonna walk upstairs. Whoops, I slipped on some things. Oh, I was gonna show you this. this is on the side of engineering and manufacturing as well. So these little dudes get a pin pressed into them, and so we have a jig for pin pressing. So basically,
cool.
all of these little parts, they fit in these little teeth back here, and then crank the vise. So I've got different jaws that do different things, but that's one thing that we make on the machine. And then these little foam things, I do infusion as well. Mm-hmm. So when I send parts to the anodizer, I send them 150 at a time, and they're all in these little spots. When I used to get them, we used to not do them this way, and they were just in a box. And they'd be missing like 5 or 6 parts of each one because they would just drop off into the tank. And
they get banged around, wouldn't they?
They get banged around, and we had them put them, use paper towels and all kinds of stuff to stack things up. But anyway, I came up with that. I'm like, well, this makes them accountable, right? Like if it shows up and it has all the slots filled, it needs to leave with all the slots filled.
Absolutely.
So
that just made seeing your presser there, it made me miss manufacturing. I really enjoyed my time in a guitar factory and coming up with all those little solutions, and
yeah, it's kind of funny. Like I said, I have a job as an architect, right? And I come home and I work out in the shop all the time. And people are always like, don't you just want to go home and put your feet up? I'm like, no, I really, this is interesting stuff. And I love this stuff. This is my Tormach. So you can see, I work in a garage. We park in here, and my car's on a lift so that we can get this car in here during the winter. Mm-hmm. And because I live in Colorado where it's cold a lot for a long period of time.
Yeah, well, I noticed all the insulation on your doors and stuff.
Yeah, last winter, I've only lived here for 2 years. Last winter, I did not have this insulation, and I didn't have that dirt up there. And I tried to work out in the garage, and like there was 3 months where I just couldn't stand being out here. Yeah. So I decided this year I was going to insulate and heat and make this a workable space all winter long because I have to. So this is an 1100 series. I can't remember. I want to say I can do like 18 inches this way and like 8 or 9 inches that way, and then maybe a dozen inches this way. And then I've got a tool changer in here that holds about 10 tools, and I would fire everything up, but I've got my air compressor off right now.
No, that's okay.
It takes a while to pump up, but I'm able to do, so there's a vise on here now, and this is a mess because I just used it this morning and haven't cleaned everything up, but I've got a vise on here so I can take small parts like if I have a blank like this, I can put it in the vise, I can flip it, I can do all kinds of things with it. Or I can take this vise off, and I've got they call it a breadboard. So some of these holes are pins and some of them are threaded. So I can actually bolt stuff right down to the machine and work on it just flat if it's too big to fit in the vise. So I don't do a whole lot of that because I just make onesies and twosies. Mm-hmm. My machinist will bolt a plate of aluminum down to his machine, and it'll just sit there and cut parts for 8 hours because it'll cut 150 parts out of one plate. So I don't do that, though. I just make one at a time. Kind of torturous. But like this, let's see. Yeah. So this was the machine program for the parts that I was making this morning. So there was 4 files for the Ibanez tool. Mm-hmm. And like you can just hit this and load it, and it'll show you if that looks familiar, the outline of that tool. Sorry, I know it's kind of glary. I'm trying to.
Oh, you got that's touchscreen?
It is.
Oh wow.
Yeah, it's pretty slick. Yeah. So there's the big machine, but yeah, I'm able to just pop the code in here, and you can see, for that program, how many lines of code there are to make that one part. Pretty in depth.
And so that's what they call G code right there, correct?
It is. Yeah, that's exactly what it is. It's G code.
And that's just all the numbers that go into the computer for what X, Y, and Z axis for the machine and tool speeds and whatnot.
Yeah. And so, like up at the top, it tells you all the tools that you're going to use for the project. So tool 3 is a 1/8 inch flat end mill. Tool 9 is I think that's my engraving tool. T10 is a bigger, like a 1/4 inch chamfering bit. And then it goes on. Yeah, there you go. It'll say it to the side what all the different tools are. And then it goes down. And the nice thing about Fusion is, whoops, let me do that. It tells you what the operation was called in Fusion. So phase 3 was what I call one of the operations. It's using tool number 20. It's going to go to the tool changing place and use my automatic tool changer. And then it's going to go to X and Y, those coordinates. And then it's going to start to move in the Z, and on and on and on. You can read through it and figure out how to make all this stuff. But
is that helpful is that helpful for troubleshooting? Like if you hit emergency stop on that and you look in the code, can you tell exactly where it's kind of deviating from what you had planned? Or
yeah, so anytime that the machine is actually running, which I can do this, I don't have to have the air compressor. Hang on, sorry for the shaky cam again. There we go. We just fired it up. So like, let's see, it's going to want me to reset everything. Okay, cool. So as the machine's moving, right, you can see the digital readout here.
Mm-hmm.
Will tell you exactly where the machine's at in 3-dimensional space. Okay, so I'm moving the Z-axis there. Great. But as you're walking through this, and there's no tool in there, so I could actually just hit cycle start, right? And maybe, hold on. Only for, when it's referenced. Hang on 1 second. It's got to reference some things, and then it'll be able to do some magical stuff. This may be boring for some people.
Well, I guarantee you my wife is not going to watch this.
Come on, buddy. You can do it. There it goes. Okay. So I can hit cycle start, I think. Yeah. So now it's going to start moving. Oh, shit. I got to stop it. Sorry. Don't do it. It was going to put a tool in there without air, and it can't do that. It would just break a tool. Anyway, so as that thing starts moving around, it'll read out here, but then as it goes through the code, I can look and see, okay, it's at Z.983. And if I think it should be at Z0 or Z1 or something else, it'll, I'll be able to say, oh, that's why that tool is going to break if I keep doing that or whatever. Mm-hmm. But yeah, you can absolutely freeze it and then start it back up or do whatever you want and sort of, do the detective work of where it screwed up, which is always fun.
So so when you're running a new toolpath, you're hovering over that thing watching, right? Like you're all hands on deck when you're demoing a new toolpath.
That's my life. Yeah, since I'm doing the prototypes, right? So I make one and then I never make another one. And yeah, so when this thing is running, I am just eyeballs on it, making sure, and hand on the escape button, just ready to to cancel out. Because tools for these things, and they can get really expensive. You might have $100 tool, and if you snap that tool, that's a Chris Benjamin right there, man. I mean, you just spin it. And
it is.
I threw one away this morning. So I didn't throw an expensive tool away. It was like a $15 tool, but it still makes you mad.
Yeah.
It's like, oh, why did I do that? And you go back and you look at Fusion and you go, yep, that's where I screwed up. Mm-hmm. And you move on. But I always try to keep it in perspective. We're going to make hopefully thousands of whatever it is that I'm prototyping. And so screwing up a tool or two on the initial run, it's not terrible. I don't enjoy doing it, but it's not terrible.
Well, I mean, what would you pay for prototyping though? I mean, sending CADs off and then yeah.
And so this machine, I don't know, I'm not afraid to talk numbers because I think it's helpful if somebody's thinking they want to get into something like this. Mm-hmm. I bought this machine used. This is a 2012 machine, and I bought it 2 years ago, something like that. So it was old when I bought it, and it was $10,000 for me to buy it.
That's so reasonable.
It's completely reasonable, and $10,000 is a lot of money. Like you could buy a car easily for $10,000, a cool car.
Yeah, but now you can prototype a car.
Yeah, and well, when I was looking at, it wasn't so much the money I was spending on prototyping, because my machinist, I mean, he's a reasonable, he's a guy who works in a very small shop. He has his son working with him. I mean, he's old school. He used to work for the auto companies in Detroit, does incredible work. He used to work in aerospace as well. So he's very detailed. Like, he is who you want your machinist to be, right? He's
Mm-hmm.
that guy. And so he would do all my prototyping. The problem was he was so busy with production. It was like, yeah, I'll get to it. And it would be 6 or 8 months before he could touch it. It's not because he's bad or a mean guy or anything else. He's just busy.
Yeah.
And prototyping is persnickety work. Like, you got to be hovering. You can't be doing anything else. And so we just got to the point, we talked enough. He's like, I think you just need to buy a machine, Greg, and I'll talk you through it. So remember, we were talking about, all those feeds and speeds and everything else in Fusion. A lot of that came from him. And that's his 30 or 40 years of machining stuff. I mean,
You send him a bottle of liquor every year for Christmas, or?
Well, this year, this year I sent him a really, really nice probe. It's like a $500 probe.
Well, that's maybe better than a bottle of liquor. So
Yeah.
$10,000. I mean, put it into perspective, though. I mean, you can pay that for a decent wood cutting CNC router. You can pay that. I mean, like if you were to get like a big Bridgeport J head milling machine in there, I mean, those aren't cheap, and they're quite a bit to maintain too. Like
Yeah.
sometimes the heads are a little funky, but I mean, 10,000. I think it's crazy. That's crazy talk. That's such a great machine for that value. I mean,
And yeah, I mean, I haven't had it that long, and it's paid for itself. I
yeah.
mean, there's no doubt, because we've been able to get tools from concept to production and
Hmm.
sell them and get a return. And, that's what running a business is about. Playing around on a piece of paper, or, not getting something to production doesn't do you any good. And this short circuited that whole thing. And I'm not a machinist. I will be the first to say I own a big milling machine. It's all CNC and it's cool. I am not a machinist. I know
Hmm.
how to operate the machine. I know how to program the machine. But at the end of the day, I'm on the phone with my machinist's name is Tom. I'm on the phone with Tom whenever there's a problem, and he's got all the answers. And this goes back to, is the knowledge mine? Should I share it and all that kind of stuff?
Hmm.
He knows that he's got my business, so he has no problem telling me whatever's in his
Yeah.
head.
Yeah.
I'm not going to run off to one of his competitors and say, "Oh, hey, I got this job for you." It's all his, because
Yeah.
he's my guy.
Yeah. Yeah.
So
I just now I want one. I think like I've always wanted a CNC router, but I mean, can you add to that? Like, is it possible to add like lathe functions in there or anything? Or I've seen like you can get like different like kind of little widgets that go in there that kind of increase axes or.
hmm yeah, so you can put on what's called a fourth axis, and both of my machines have that capability. So the wood router that's over on the other side of the garage and this can have a fourth axis function. So this one, I want to say they're like $4,000 or $5,000 for a fourth axis, which you kind of go, wow, that's a lot compared to a $10,000 machine. New, I think these machines are 25 to 30, somewhere in there.
Yeah.
By the time you get it all outfitted, and holy cow, you can spend. I think I spent $3,000 on tools for the machine, but you have to. That's just the way it works. But yeah, you can buy that fourth axis, and it goes on there, and so now you can do turning operations. You can't do anything terribly complex or big because of the constraints.
Hmm.
But like if you're making custom screws or bolts or shoulder bolts, or turning things down so that they'll fit one thing versus another, like the string winder that you just showed me, if you were going to turn those parts, this would be perfect to do
Yeah.
that. And I've been trying to sort through whether or not I should get one of those. I'm investing a lot of money right now in inventory, because I'm just a dude spending money, just like
Uh huh.
you. Like, instead of going and buying hamburgers and a 12 pack on Friday, I put that money in a sock and I go out and I buy mahogany by the 100 board foot so that I can make tools and things. And we've, again, it always feels egotistical when I talk about my business, and maybe I need to get over that. But we tripled the amount of business we did from 18 to 19. This year, it's on the path to triple again. And the cost of growing is like, you sell 3 times the amount of stuff, great, 3 times the amount of money is going in, but you have to front 3 times the amount of money to get the inventory, right?
Yeah.
It's a terrible game. I never knew that before I got into manufacturing, that you're never going to spend any of the money that you get until you level off. You're constantly having to reinvest. And so I'm looking at right now, do I spend $5,000 on a 4th axis, or do I spend $5,000 on stuff to make other things, paying Tom to make stuff or paying my laser guy to make stuff? And right now all the money's going in their pockets, which is okay. I have a job, so I'm okay with that. We're growing a company. So
I think it's interesting that that business, that dance of prioritization it drives some people crazy. Like I don't know if I'm cut out for it, because it all seems like gambling to me, like putting my money into this and then like, well, I hope people buy all that stuff, like
it's absolutely that way. And I look at the machines, like this big machine. Mm-hmm. I could turn around, I could sell this tomorrow.
Yeah.
Like I could put it on.
That would not bother me at all. Spending $10,000 on that and sticking it in my garage, that in my mind would not be a gamble at all, because I would just have it.
Right.
And it would be awesome for me.
When we have the newest new thing, and it's $8,000 or $9,000 to get the first batch of them made, and to anodize and get the packaging made for it, and you don't know if you're going to sell one of them, right? Like it's like, again, I could almost buy a car for that.
Yeah.
and so far, knock on wood, we've been really lucky, and I think part of that is just making tools and making things in a manner. I always make something that I think I would want, right? Like if I start to cheapen it up, which everybody goes through that phase. Everybody value engineers their products. What can I do to take out a little bit of money here or there, or make the process easier? And some of them, it's like, that actually made it a little bit better or something like that. And then some of them, it's like, no, it got cheap. Forget it. It either goes in the trash bin and we don't do it, or we do it the hard way and we just, put it out there. So, but a couple other quick things I'll flip around here. Big bandsaw. Oh, baby.
Oh, yeah.
This is a 19-inch Rikon, so it's built like the Italian ones. If you know what the difference between the Italians and I don't know what the other ones are.
Are the Italians blue and the other ones are green, or because I've seen Rikon in green?
Rikon changed their color scheme. I think they changed it again. It just happens to be the year that I bought it, they were doing blue stuff. But the way that the mast is over on this side, there's an Italian way to do it that I can't remember the name of the company, but some of these were actually, I think, made by the Italians, and then the Rikon folks just, put their badge on it. But this is another like go through the drawers kind of thing that would take an hour. But my wife's grandfather was a machinist for TWA, and this is his old toolbox. And these are his old tools with the calibration notices still on them. So,
oh my God.
He passed away the day after Thanksgiving this last year, and I got all of his machining stuff. And this is like the coolest thing I have in my shop right now is all of his stuff.
I love tools that have that. I wouldn't want to say haunted, but like it just, I don't know, man. I love that stuff.
All of these little abrasives, these are like you can't hardly find some of these things anymore.
Yeah.
But no, I always say it this way, Ian, and it's true. I have a lot of tools from relatives that have passed away, and I feel like it's almost like they're in the shop working with me.
Yeah.
And I don't know how to say it any other way, but like these are his go-to calipers. These are my go-to calipers now.
Yeah.
And it's like, well, if these worked for him to build airplanes, they're going to work for me to do my little tools here in the shop. So
absolutely. Yeah,
Yeah.
I've got a few things for my grandfather too, and they're very special to me. Speaking of the Rikon bandsaw, I had opportunity to use in one of the shops I worked at. They had just the little 9-inch Rikon, and it was super usable. Like,
Yeah.
it was a really good. Nobody makes a good. Everybody, all of the 9-inch bandsaws are real throwaway kind of garbage stuff, like the Ryobis or whatever. But that
Yeah.
Rikon was a that somebody took the time to make a decent 9-inch bandsaw. Really said a lot to me.
I've seen a lot of those on people's benches. I mean, I
Mm.
think if I remember right, the 9 inch is the one that'll actually fit on a bench, right? It doesn't have
Yeah,
a
yeah,
stand.
it's a bench top.
Yeah.
Yeah,
Yeah. No, they make a really nice bandsaw. I went through some. I spent a fortune on that thing. I feel like it was like $2,000 maybe
yeah.
for a bandsaw that just feels really spendy for me.
Did you say that
But
was
I wanted to.
18 inch or
I think it's 19
19?
clear.
Yeah,
I wanted to be able to cut guitar tops on it in one shot,
yeah.
and that's what you got to do. In the back corner with my weed whacker on it, I've got like a 16-inch planer and a joiner and some other things that
Mm.
so I worked in big rock and roll for a few years, right around the year 2000, doing big shows. So more stage managing. We had an audio and video company. We did lighting too, and we had a stage as well. But we did big radio shows and things like that all around the country. Everything's got to be on wheels. So yeah, everything in here is on wheels, so I can put it where my wife parks when she moves her car out. I can work on it there. So
That's cool.
yeah, the Karmann Ghia is a fun story, and it goes right along with that. So the Karmann Ghia up there, I restored. My other YouTube channel, which is Greg's Garage. I restored that car on Greg's Garage, so you can watch it sort of start to finish
Oh
when it was a
yeah.
complete piece of junk, and did a ton of welding on it and everything else. But I did it in a 2-car garage, and we parked an F-150 and a Nissan Murano in that garage along with my car. So it's like, the ultimate, like, how do I make this space work for me?
You have some wife there. I'm going to assume.
Well, yeah, I have a great wife. That doesn't mean she doesn't complain about some of that
Uh huh.
stuff or how much time I spend out here.
Yeah,
But
that's very
um,
traditional.
she's a graphic designer, and she actually started working for Skyscraper Guitars full time in December.
Oh
So
wow.
she does all of the packaging design, I call it marketing stuff, but it's not like I'm not a salesman. I do a terrible job at that. But anything that we need for the website or whatever, she designs it all. So there's, since she started working for us full time, she gets to work here at home, and it's like I told her, you have unlimited vacation, and you can tell your boss to screw off anytime you want,
Uh
and
huh.
that's been a really great thing to be able to do that. At some point, I'd like to be able to do that too, but so yeah, my leash got a lot longer when that happened.
As the pros outweighed the cons. Yes,
Yeah.
I hear that.
So
Yeah, we don't. I haven't figured out anything like that here. But my wife is tolerant of the YouTube hobby that I have now, so that's nice. Although she's texting me now, wondering what's going on. So I should probably
we're
get
probably
going.
talking too long. I'll extend this too. I mean, if you want to have a short conversation specifically about three-dimensional stuff or any of that, or if there's like, hey, I want to show my viewers how to do X, Y, or Z,
Uh huh.
and you think that I might be able to help you, I'm more than happy to
Well,
sit and chat about those things. I mean, like, I think this
and
is great stuff.
and vice versa. Like if you do like a little change on a part or something, or you figure out some way that workflow is like you know increased in your your tool paths or something like that, like reach out to me and say I've got this new thing I want to share with you on the the CAD stuff or the CAM stuff or the any of that stuff, because I think like that stuff I think would be good as little like almost 10 minute, I think 10-minute tops, kind of like short snippet kind of things. Hey Greg, it was really awesome talking to you, and man, good luck with everything, and cool stuff.
Well, thanks, Ian. It's wonderful to talk to you. It's always so much fun to talk to other guitar nerds. They're like, you can smell your own, right?
It's yeah.
and,
There's a stink for sure.
and it's just wonderful to talk to other people that are into this geeky kind of stuff. And yeah, it seems kind of rare because I'm stuffed here in my house most of the time and don't get out a whole lot, especially
Yeah.
right now with all the stuff going on. But yeah, it's awesome, Ian. Thank you.
Greg, thank you so much, man. I'll talk to you later.
All right, we'll see you.
All right, take care.